All right, we are looking at section 6.8, where in this section we're going to be looking at what is called the counting principle. If you look in the front in your notes and on the board, we have a safe, or if you look at the top, it says is when somebody has something very valuable, a lot of times you keep it in a safe. Reason for that is because there's a certain combination that requires you to open it, and for the most part, you alone are the only one who knows that specific combination. Depending on the number of specific combinations that there are, we can use two different ways in order to solve it. So if you look at this safe specifically, it says like this uses a 2-number combination and has 4 digits to choose from. Okay, so the one way that we could possibly find the combination of this is to be able to make a list of all of the combinations that it could possibly be in order to open the safe. So the first method is called the using the counting tree. So this portion right here, more specifically, these numbers 1, 2, 3, and 4 mean that in the first number, it can either be a 1, 2, 3, or 4. Once you have established what that could be, then you go to the next one, which is the second number here. So if the first number was 1, then the possible combination could be 1, 1, 1, 2, 1, 3, or 1, 4. If it was 2, then it could be 2, 1, 2, 2, 2, 3, or 2, 4, so on and so forth. So if you look at that second piece of the tree, this allows us to figure out the total possibilities that there could be. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 possible combinations or 16 possible outcomes. All right, so there's only one that could be the correct combination, but there are 16 possible outcomes. That is one way of solving it. The other way is using the counting principle. Okay, the reasoning why we probably use the counting principle in most instances is because not every, there's going to be sometimes a very, very large list of possible outcomes. For example, so like say you take your lockers. Now I'm not sure what the lockers numbers go for here in Amherst, but I remember that most locker combinations are between 0 and 59. Okay, so there are 60 numbers. Okay, and usually there are 3 digits, 3 different ways. So it goes like your locker combination could be another number to the right, go to the left to a number, the second number, and then finally the third number. So that makes it a lot of different combinations since they give us 60 numbers, and there has to be 3 possible, 3 possible numbers to make the combination work. So here's how you determine how many possible outcomes there are for the counting tree. So if you look at the first number, like here, first number, second number, and then finally the third number. How many possible numbers could there be? Well, between 0 and 59, there'd be 60. Same thing goes for number 2, and same thing goes for number 3. And you simply multiply 1 times 2 times 3. So you go 60 times 60 times 60, which gives you 216,000 possible outcomes. All right, that'd be really, really tough to make a list of all those outcomes. All right, it was a lot easier for the 16 possible outcomes, which you could easily just use the counting method saying, okay, the first number there are 4, so it'd be 4. And the second number there are 4. 4 times 4 equals 16, the same number we got when we used the tree diagram. All right. So if we go to the next page, this is just being able to figure out the total number of possible outcomes that you can have. So you just take the possible outcomes of the first event, again, number of outcomes in the second event, which then will equal the total possible outcomes. If there's a third event, like we did with the locker combinations, you can just add another event. So if you look at here, we have somebody who has different possible outfits that they could choose. Okay, so it looks like it's shirts and pants. So if you look at, like, say, like this is shirt number 1, shirt 2, shirt 3, shirt 4, and shirt 5. So there are 5 possible shirts you can choose from, and there are 1, 2, 3 different types of pants. So since there's only 2 events, you take 3 times 5. 3 is the choice of the pants, 5 is the choice of the shirts. So there are 15 possible outcomes for choosing a different outfit combination. Okay, and that is being able to use the counting principle. Hope this helps. Until next time.